Hello everyone, this presentation is about V3Det vast vocabulary visual detection dataset. Object detection is the cornerstone of various real-world applications and it has been developed for years. It is an active research area where there are emerging new tasks. For example, long-tailed and few-shot detection, and more recently, open-world object detection aims at detecting any categories, giving only category names or descriptions. With the continuous development of detection, datasets also undergo iterations. For example, we'll see Coco, open images, and Elvis. They make indispensable contributions to the development of this task. However, compared to image classification, object detection datasets has a much smaller number of classes. For example, Elvis has around 12,000 classes, but a recent image classification dataset, Bamboo, has 119,000 classes, which is 100 times larger than Elvis. The detection datasets with a limited number of classes are insufficient for training and evaluating detectors in the real world. To support the development of more general visual object detection, we propose V3Det, a vast vocabulary visual detection dataset. Our V3Det has three appealing properties. First, vast vocabulary. It contains bounding boxes of objects from over 13,000 categories on real-world images, which is 10 times larger than the Elvis. Second, hierarchical category organization. The vast vocabulary of V3Det is organized by a hierarchical category tree, which annotates their relationship. Third, rich annotations. V3Det comprises processively annotated objects and descriptions of each category written by human experts and the ChatGPT. This table presents a detailed comparison of various datasets. Notably, our dataset has significantly more categories, extending others by more than an order of magnitude. V3Det has a suitable amount of images and boxes, which is sufficient to ensure the stability and reliability of experiments without requiring huge training cost. We also offer a hierarchical category tree to explore category relationship, and our category descriptions are thoughtfully designed to bridge the gap between visual and language knowledge. This is the illustration of our annotation pipeline. The step 1 is the coarse-grained annotation. We divide categories into 53 coarse categories. Each group is assigned to annotate one coarse-grained category. The step 2 is the joint verification. Annotations from all groups on the same image are merged and presented together to find missed objects and remove duplicated boxes. The step 3 is called fine-grained annotation. After step 1 and step 2, we annotate boxes with coarse categories. For each box with coarse-grained category, some recommendations are given to annotators for fine-grained annotation. The final step is inter-category verification. Objects annotated with the same fine-grained category are presented together. Annotators will verify and correct any misclassified objects or inconsistent annotations. Here are some dataset analyses. We can observe that the images in V3Det have a larger number of classes. The mean image resolution of our V3Det is higher on Coco and Elvis. The object scale in our V3Det is comparable to that of Coco and open images. We report benchmark results of closed-set object detection on V3Det. We can observe that existing detectors can achieve a reasonable performance on V3Det, and the result comparison using a strong foundation model shows that V3Det is clearly more challenging than Coco and Elvis. We also evaluated the open vocabulary object detection on V3Det. It shows that OVD trained on other datasets perform unsatisfactory on V3Det, and V3Det can significantly improve OVD performance. Finally, there are some visualization of annotations in complex scenes and fine-grained categories. In our next step, we will use V3Det to help multimodal large language models. We are annotating the segmentation masks, image captions, and high-quality QA based on V3Det to improve the fine-grained and open-world perception ability. Those new annotations will be public within this year. Our dataset and source code are now available. Please scan the QR code for more information. Thank you very much.